my presentation on magnetism in nature. So what is magnetism? Magnetism is a force created by moving electric charges. This motion generates magnetism. Every electron acts like a magnet due to its spin and orbital motion. Only materials with unpaired electrons and domain structures can become magnetized. There are specific materials called ferromagnetic materials. These are substances that are strongly attracted to magnets due to their domain alignment. Examples of this are iron, nickel, and cobalt. Higher temperatures impair magnetism. So as the temperature rises, the atomic vibrations increase, and this disrupts alignment and magnetic forces. So what is a magnetic force? It is the force experienced by a charged particle within the field. This is also a vector quantity. It can further be explained by its equation, where the charge times the velocity times the magnetic field times the angle between the field and the velocity gives us the magnetic force. Remember, magnetic force is always perpendicular to the velocity of a charged particle, and we can see that clearly in this illustration over here. We see the velocity, and then we see the perpendicular magnetic force. Here is a video from our lab experiment. Compass arrows are magnetized and pivot freely. The magnetic field exerts a force on the needle. The needle repositions until it aligns with the magnetic field again. As you reorient the compass, the needle will realign with the magnetic field. The needle represents the direction of that vector field. So how does magnetism appear in nature? Magnetoreception is the answer. Earth is a giant magnet. Organisms can utilize the Earth's magnetic field for migration and orientation. This is a phenomenon known as magnetoreception. It's more common than we think. It's seen frequently in birds, sharks, salmon, honeybees, turtles, certain insects, bacteria, and many more examples. Here are 3 examples. Hammerhead sharks in the family Sphyrnidae migrate following magnetic fields, and they return home annually. Migratory birds such as geese, waterfowl, shorebirds, songbirds, etc. detect the magnitude and direction of the magnetic field and follow specific patterns. There's a specific bacteria called Magnetospirillum. It's a gram-negative aquatic bacteria that produces magnetosomes. We can see that chain-like structure here. And it uses those magnetosomes to orient themselves in the water column. And here is a video of an experiment with juvenile sharks following magnetic fields.
Sharks used in magnetoreception studies are housed in a 7-meter diameter tank. The tank is surrounded by a coil consisting of 100 turns of 18-gauge copper wire. Power to the coil is provided by a 13.8 volt, 1.5 amp power supply.
Okay, go ahead.
Applying power to the coil alters the magnetic field within the tank.
And off.
To test the hypothesis that sharks can detect magnetic fields, the animals are first conditioned to feed over a PVC quadrat in the presence of the altered magnetic field.
5, 4, 3, 2, 1. Magnet on.
The sharks are subsequently presented only with the altered magnetic field.
Shark magnet trials, March 26th. 5, 4, 3, 2, 1. Magnet on.
They respond by converging on the quadrat even though no food is present. This experiment demonstrates that these sharks can detect magnetic fields.